Welcome aboard. Countdown for our incredible journey has begun. As 3D space explorers, we're going to leave our planet and travel to extraordinary places. From the beautiful and sometimes mysterious planets of our solar system to distant nebula and swirling galaxies. But before we begin our incredible 3D journey, let's review important pre-launch setup steps. The audio tour is designed to play along with the correct image. So please make sure you have all 5 image strips in the correct order, beginning with strip A and finishing with strip E. Strip A, image number 1, should be inserted into the projector now. When you hear this sound, simply advance the strip to the next image. After experiencing the first 5 images, you'll hear this sound. This sound indicates that it is now time to insert the next image strip. Strip B, image number 6. If at any time the images are out of order with the audio tour, just pause the tour and insert the correct image. You may also pause the CD to view the 3D images for as long as you wish. Now buckle up as we blast off on an awesome 3D adventure.
3, 2, 1, 0, ignition, liftoff.
Image 2, Earth. What an incredible view! Our home planet, Earth, is the only planet we know of that's able to support life. Why? It has water and air. Almost 3/4 of our planet's surface is covered with water. And Earth is surrounded by an atmosphere, or thin layer of gases, that protects us from outer space, creates our weather, and gives us air to breathe. At 93 million miles from the Sun, conditions are just right for life to exist on our blue jewel of a planet. Image 3, the Moon. The Moon is Earth's closest neighbor in space. A lifeless ball of rock, it's covered with craters and dusty gray soil. The darker spots are called maria, areas that were covered with molten lava billions of years ago. Because it has almost no atmosphere, there is no air or weather on the Moon. Where did our Moon come from? Most astronomers believe that an object about the size of Mars smashed into the Earth 4 billion years ago. Debris from that collision eventually formed the Moon. Image 4, Moon detail. The Earth and the Moon, what different places. Compare the stunning blue oceans of planet Earth to the dull gray of the Moon. In 1969, we visited the Moon for the first time. Astronaut Neil Armstrong became the first of 12 people to walk and jump about the lunar surface. The Moon's gravitational pull is only 1/6 that of Earth's. This means a person weighing 180 pounds on Earth weighs only 30 pounds on the Moon. Computer, bring up database for journey overview now. Image 5, our solar system. Ah, yes. We're going to travel through our solar system. This group of planets and their moons, comets, and asteroids. The Sun's gravitational pull keeps everything moving around it on paths called orbits. You can see the inner planets, Mercury, Venus, Earth, and Mars, are small and rocky. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are huge gas giants. Mysterious Pluto doesn't fit into either group. Please insert image strip B to continue the journey. Image 6, Venus. As we head towards the Sun, we pass by cloudy Venus, the second planet in our solar system. Of all the planets, Venus is the hottest, with a temperature of 860 degrees Fahrenheit. Probes taking pictures from high above have shown us the Venus beneath the clouds, a dry, rocky planet that's dotted with volcanoes. While we don't know if Venus's volcanoes are still active, its largest is almost as tall as Earth's Mount Everest. Prepare for Mercury flyby. Image 7, Mercury. The closest to the Sun, Mercury, is a small, airless planet. One of the hottest planets, the temperature during the day is over 800 degrees Fahrenheit. With all of its craters, Mercury looks a lot like Earth's moon, but parts of Mercury remain a mystery. The one spacecraft to visit this planet only mapped half of its surface. Like Venus, Mercury doesn't have any moons. We're approaching the Sun. Things could get a little hot. Image 8, the Sun. Believe it or not, the Sun is like the stars we see at night. It's just much closer. An immense ball of superheated gases, scientists believe the Sun has been shining for about 5 billion years. Even though the Sun is just an average-sized star, it's enormous compared to everything else in the solar system. 1 million Earths could fit inside the Sun. Our sensors have picked up a passing comet. Let's take a look. Image 9, Comet. It's a beautiful sight, isn't it? Comets are pretty simple objects. Frozen chunks of water ice with a little space dust and gas mixed in. These icy snowballs are usually a mile or two wide. When a comet gets near the Sun, the comet warms up and releases water, gas, and dust. Some comets, like this one, can grow a spectacular tail that stretches away from the Sun for millions of miles. Let's check out our database to see what we have on famous comets. Image 10, Comet Halley. Ah yes, Comet Halley. Probably the most studied comet, it's named after astronomer Edmund Halley, the first known person to predict when a comet would return. Comet Halley is a regular visitor, looping around the Sun once every 76 years. It'll be back in the year 2061. As this view of Comet Halley shows us, there are two kinds of comet tails, a blue, gas tail, and a brighter yellow tail made from comet dust. Prepare for Mars approach. Please insert image strip C to continue the journey. Image 11, Mars. We won't find little green men on the planet Mars, but we will find reddish-colored soil, fierce dust storms, and polar ice caps. As the seasons change on Mars, its ice caps grow and shrink in size. Mars is orbited by two tiny moons called Deimos and Phobos. Phobos is the bigger of the two and shaped like a potato. These moons may be ancient asteroids, caught up in the planet's gravity long ago. Computer, scan the Martian surface, please. Image 12, Mars surface. So far, the robotic probes we've sent to Mars haven't found any signs of life or even liquid water, but they have detected water ice just beneath the dusty surface. Mars may have had water flowing on its surface long ago, but the Mars we see today is a rocky red desert under an orange sky. One day humans may walk on the red planet. Imagine trekking through Valles Marineris, a canyon on Mars as long as North America is wide, or climbing up the side of Olympus Mons, the tallest volcano in the solar system. We'd better be careful as we move on through the asteroid belt. Image 13, the asteroid belt. Between Mars and Jupiter, we pass through this area of space filled with thousands of small, rocky bodies, the asteroid belt. Asteroids are thought to be debris left over from when the solar system formed. While most asteroids are found in this belt, some do orbit closer to the Sun and Earth. In fact, it could have been an asteroid that crashed into our planet 65 million years ago and wiped out the dinosaurs. Phew, we made it through safely. Now approaching the gas giants. Image 14, Jupiter. Jupiter is the fifth planet in our solar system and the largest of all. It has over 60 moons. Like the three other gas giants, Jupiter has a small rocky core at its center. Because of the planet's rapid spin, its thick clouds are stretched out into bands of color. And how's this for wild weather? Jupiter's lightning bolts are 10 times stronger than those on Earth, while its famous Great Red Spot is a 300-year-old hurricane. Now departing for Saturn. Image 15, Saturn. Seen from this distance, the bright rings of the sixth planet look pretty solid. But Saturn's rings are actually made up of billions of small ice chunks that circle the planet in a space no more than a mile wide. Looking at the rings, we can see a dark band called the Cassini Divide. This isn't empty space, just an area within the rings where there's less material to reflect the sunlight. Saturn also has 30 known moons. Preparing for Uranus flyby. Please insert image strip D to continue the journey. Image 16, Uranus. At 20 times the Earth's distance from the Sun, it's cold out here at Uranus, where the temperature at its cloud tops is minus 340 degrees Fahrenheit. Like the other gas giants, Uranus has a ring system and lots of moons, at least 21. The most amazing thing about Uranus is that, compared to the other planets, it's tilted so far over that it spins on its side. Why? Well, according to one theory, long ago, a large asteroid crashed into the planet, pushing it onto its side. Preparing for Neptune approach. Image 17. Neptune. Welcome to the windiest planet in the solar system. When the Voyager space probe passed Neptune in 1989, it detected winds 10 times faster than a hurricane. These winds are driven by the planet's superhot core. Triton, the largest of Neptune's 11 known moons, is the coldest place in the solar system. Despite the freezing conditions on this moon, it has active geysers that spew out jets of nitrogen ice and gas. Hang on. Sensors indicate we've drifted too close to the planet. Computer, activate reverse thrusters now. Image 18. Neptune's rings. It looks like we're okay. We just got a little too close to Neptune's rings. These rings appear to be mainly made up of dust with some smaller rock chunks. That's why we didn't see them at first. Astronomers believe these faint rings formed millions of years ago when two of Neptune's moons collided with each other. Over time, the material would have been pulverized into these smaller particles. We just have to maneuver around the bigger pieces. Once we're clear, it's on to Pluto. Image 19. Pluto. At the edge of the solar system, tiny Pluto orbits the Sun once every 248 years. This frozen planet is the smallest in the solar system. From the surface of Pluto, the Sun appears as an incredibly brilliant star in a black sky. Because of its size and strange orbit, some astronomers believe Pluto is actually a large asteroid or comet. Future space missions will help us learn more about this mysterious body and its only known moon, Charon. Preparing for Kupier Belt entry. Image 20. The Kupier Belt. Leaving Pluto behind, we move through the Kupier Belt, an area of space that extends out approximately 7 billion miles. Millions of comets are found here. Like the planets, comets orbit the Sun. Astronomers believe that comets in the Kupier Belt take 200 years to go around the Sun once. Comets with orbits of thousands of years are found in a distant region of space called the Oort cloud. Prepare for solar system departure. Please insert image strip E to continue the journey. Image 21. Eagle Nebula. Beyond our solar system, we drift through space that's mainly empty. After all, the nearest star to the Sun, Proxima Centauri, is 4.2 light-years away. Between stars, we find nebula, large clouds of gas and dust like this one. Nebula are stellar nurseries, places where new stars form from the leftover stuff from other stars. Speaking of stars, let's check the database for black holes. Image 22. Black hole. This is one space object to avoid. Black holes form when really massive stars collapse and end their lives in an explosion called a supernova. This creates a gravitational pull so strong that not even light can escape. If a black hole's near a star, its gravity will pull the star matter into it. This star stuff gets super hot giving off X-ray radiation, which we can detect with special instruments. Black holes likely exist in every galaxy, including our own. Preparing for galaxy departure. Image 23, the Milky Way Galaxy. The Sun is just one of about 200 billion stars that make up our Milky Way Galaxy. From Earth, all of the stars we see in our night sky belong to this huge star city. Looking back at our home galaxy, we find the Sun in one of the spiral arms about halfway out from the galaxy's center. The Milky Way Galaxy is huge. It takes light 100,000 years to travel from one end to the other. Scanning for other galaxies. Image 24, Andromeda Galaxy. The universe is filled with galaxies of all shapes and sizes. This is the closest major galaxy to the Milky Way. But remember, space is big. Even though it's our neighbor, it still takes over 2 million years for the light of the Andromeda Galaxy to reach Earth. The Milky Way and Andromeda Galaxy are moving through space towards each other. Could they collide? Well, it's possible, but don't worry. It wouldn't happen for another 5 billion years. Computer, take us back to Earth, please. Preparing for Earth arrival as we conclude our journey. Image 25. Return to Earth. While astronomers study distant galaxies through telescopes from here on Earth, rockets and space probes explore the planets of our solar system. We can visit these special places again, anytime we want. All we need to bring is our curiosity and imagination. We hope you've enjoyed this 3D journey through space. Welcome back to planet Earth. The Journey into Space music-only track is next. It plays for approximately 15 minutes. Launching in 5, 4, 3, 2, 1.